Hello, beautiful people on the internet. Welcome to Daily Codes. I'm your host, Dalmas, and today I'm going to be talking about unit testing and how to do unit testing using Python. Basically going to be taking you through doing unit testing using pytest and how to do unit testing with continuous integration and continuous development, more so those small badges that you usually see on Git. I'm also going to tell you why unit testing is important for when you're doing data science and when you're doing data engineering or programming in general. Unit testing is a process of testing your code. It is writing code to check that your code is correct, which sounds kind of weird, but it is very important to do tests in any kind of system that you develop. For example, if you are a car manufacturer and you're building a whole car as a system, it is usually important to do tests on the different parts of the car before you sign off that the car is safe or the car is ready to use. For example, you can test the tires, and when you're testing the tires, you test it in different scenarios. When it's raining, when you're going at different speeds, you see how the tire is performing. You can test the lights, you can test so many parts of the car, and that relates to when you're writing a piece of code, or when you're developing software, or you're developing a data engineering pipeline, or you're just doing data science and you're writing a piece of code that does something. So unit testing, when it comes to programming, it's testing your blocks of code to see that your code functions as you expect it to function. So unit testing will come from the direction where you have a piece of code, for example, a function or a class, and you expect the class to perform in a certain way in several scenarios. You will be testing the class or the function to function, or to test the function to function. Yeah, you test the function to function in that way, based on the scenarios. For example, if you're writing a function to increase somebody's salary, let's say you're working on a human resource management system and you want your function to be increasing someone's salary when the function is called, you will need to test this function that you've written in several scenarios, so that you see that the function is working properly in all those scenarios. For example, if your function is provided a negative input to increase the salary, how should it function? What if your function is given an input of increasing salary 10 times what someone has been having? How should it behave? So these are the things that you do to your function, or it is the way that you test your function to see how it will behave when the function is either in production, or your function or a class is being used by some other person and they're giving it several inputs. So unit testing is testing a unit of a piece of code to see how it behaves when it is exposed to several scenarios, so that you're sure that you wrote your piece of code well, and it can handle all those situations that are given to it. And these scenarios that you're talking about are usually user stories, where the user tells us that I want, when I'm increasing salary, the salary should not go down. I want, when I am increasing salary, the salary should not double. It should be just a percentage, which I should provide as an argument to the function. And based on these user stories, you can now write your function and expose them to all these scenarios. And unit testing comes from a philosophy or a line of thought in terms of programming, which is called test-driven programming or test-driven development, TDD. And in TDD, you write your tests before you write your code, in a way that you first write, you create the structure of your code, and then you write your tests before you write the code, so that whenever you write your code, you can now expose your code to all the tests that you wrote before. We write tests before you write code because whenever you write code first, it becomes very weird and very unlikely for you to write tests for the pieces of code that you've been writing. And also, if you wrote the code first, there is usually no budget for the time to expose your code to the several tests, either feature tests or unit tests. We shall look at feature tests in the future. Yeah, so that is unit testing. And now to do unit testing in Python, there are several packages that are used to do unit testing, but the package that I'm exposed to are two. There is behave and there is pytest. So pytest is the one that we're going to use here, and we're going to develop a class, an employee class, because I've talked about human resource. So we're going to develop an employee class and a manager class, and we're going to use pytest to do unit testing for these classes. We are not going to stop there. We are going to integrate this code with GitHub. So we're going to use codecov to calculate the percentage of a code that is covered in unit test, and then we're going to use Travis CI to check if our tests are passing or failing. So I think in the popular repositories that you've been looking at, if you've been looking at popular repositories, for example, pandas or NumPy repositories or SciPy repositories, they usually have these badges where you can see that the tests that are being done on this on that code is passing, and how much of the code is covered using tests. So we'll use Travis CI to do that, which will be showing us whether the tests are passing or failing, and we're going to use codecov to show us the percentage of the code. So by the end of this video, you should be able to write pytests. Then you should be able to use Travis CI, integrate it with your code, and then codecov. Travis CI can be used for free. Also, codecov can be used for free if your code is public, but you pay for it if your code is private. So without so much chatting, let's get to it. And as we're getting to it, if you like this content, please give it a thumbs up and consider subscribing so that we can continue giving you this content, and you can be notified. You can click on the notification to be notified every now and then whenever I post the video. So let's get to it. Yeah. So now I am on GitHub, and I'm going to create a new repository, and this repository I'm going to call it employee so it is let me just call it HR management system. Then the description is going to be, this is called for unit testing, unit testing YouTube video. it should be a public. Add a readme file. We may need to add some stuff. We need a template as the Python template. Yeah, so I already integrated codecov and Travis CI with my repositories, but if you don't have Travis CI and codecov, it is very easy to integrate them. Let me just open a new let me show you how. So let me open GitHub, a new window, then you can go to marketplace. Then from there, in the marketplace, you search for Travis CI. So Travis CI, you can click on it. Then when you click on it, you can now configure how you access it, and then you give the repositories that are to access your Travis CI. So you can see that it is open source, and for open source it's 0, and then for free trial 1 person it's $69, and if you're using it 3 people it's $199. So you can get Travis CI from the marketplace of GitHub, the same as codecov. So I can come here to marketplace, then I look for codecov, and it is also here. So you can configure access for me, and then integrate it with your repositories. Yeah, so it is straightforward on how to do this, and we shall continue seeing how to work with this. So I'm going to say that grant your marketplace app access to this repository. So codecov and Travis CI, then create repository. So remember, Travis CI is used to check whether the tests are passing or failing. Then codecov is used to check the percentage of code that is covered by the tests. So we have created the repository. So we're going to clone this repository. So cd into HR management system. This is what we see. Then ls minus a minus all. So this is what we see. So we are going to use Python. So I'm going to determine the Python version that we're going to use. So pyenv local for this folder, it should be 3.10.0. So that installs Python 3.10.0. here is my Python version in that folder. Then I'm going to create a virtual environment. So Python -m venv right. So we have now the virtual environment created. So let's activate the virtual environment. So it's venv being activate using bash. So if you're on Windows, there is a different way of activating a virtual environment. So this is what we are going to be working with. So we need to install some stuff. I think we will need to install pytest. So we're going to do install pytest. I doubt if we'll need any other package in what we are going to be coding, because we are going to create a class for employee class in the HR management system. Okay, so let's open VS Code from here. So here is where we are. The next thing I'm going to do is to create the structure of the project. So I'm going to have a folder called source, that is src, where it will have it. So the source folder contains all the code. I should increase the size of this. This cannot increase. Yeah, so the source folder contains the source code. Then we are going to have another folder for tests. So this is where we're going to be writing our tests. Yeah. Yep. So let's start with, so according to test driven development, we need to determine the tests before the source, but this, our source code is going to have a file here called employee.py. So this will contain the employee class. Remember, according to what I've been telling you, that each class should be in its own file. So I'm going to create another class called manager.py. So manager.py will inherit from an employee class. So the employee class will be a class employee. Then I'm just going to pass here. We shall work on it later. Then this should be also a class manager. And we are going to pass here. Sorry. Pass. So we have employee class and we have the manager class. I think it will be good if we also define the constructor for both of them so that we know what's going on. So employee class, we shall define the constructor. Sorry, this one takes in self. The employee's first name, and the first name should be string. We use typing. Then middle name, and also the middle name is a string. Then we're going to surname, and the surname is also string. I think that is all. We also need a date of birth. Let me make this bigger. So we'll need initial salary and date of birth. Salary. Initial salary, which is a string, and finally date of birth, DOB, which is also a string. So we pass this. So this is a function, This is pass. Something is wrong. Yeah, here. Alright, now that we have seen the glimpse of how the structure of the source code will look like, we are going to write the tests because we are to write the tests first. And obviously you already had design sessions if it is a system that you're building, and you know how the structure will look like, the kinds of functions that you're going to write for your classes and so forth, and the classes that you're going to build. So based on the designs that you have, you can create tests beforehand before coding the whole system. So now um, I'm going to create files for testing, and the first one I'm going to test employee. So it takes the tests. The tests take the same structure as the source, but the naming will be different. For example, the pytests here is going to look for files that whose names begin with the test underscore. So this is going to be employee. Employee.py. So all the tests about the employee class and everything that is inside this file, the tests will be written here. Then a new file for test manager.py. So all the tests for manager, this manager class, and everything inside this manager.py file will be inside this. So all the tests, if there were other folders inside the source here, there will be same folders in the tests, so that it is your project is well organized according to tests, and someone will know what you're testing. So if inside the test employee file, I know that I'm testing everything inside the employee class. So now I'm going to work on the test employee class. So to write the test the tests for the employee class, I'm going to use pytest. I tell you that I'm going to majorly use pytest to do this unit testing. So we're going to import pytest, and then we're going to import the class that we are going to test. So from source dot employee. So remember that our employee file is here, so we can just import employee. So from source import employee. So everything in this file will be imported inside here, and now we can start testing several scenarios for creation of the employee. So employee is a class, it creates an object. So we could first begin tests on object creation. So I'm going to create a class here, and this class is going to be test. So for pytest, whenever it encounters a class that begins whose name begins with test, then it knows that this is a test class. Then it runs test functions inside that test class. So, and it ignores the rest. If the class does not begin with test, then it will be ignored. So employee, test employee, object creation. So that's the employee object creation class, and it will contain now tests for several scenarios. So the first scenario is when we look at employee here, somebody may decide to pass a negative salary. So we could say define a test for that. So I'm going to say define test employee creation, employee object creation, employee object creation on negative salary. and it takes self. So what we want is whenever this object is created, we don't want someone to pass negative salary. If someone passes negative salary inside here, then there should be an error that is raised, either a value error or a type error or any other error. So whenever someone creates this object, there should be an error if the salary is negative. So the pytest has a context manager that wraps creation of an object, and that context manager expects an error. So if your class throws an error or an exception, then pytest will be happy that okay, it's expecting an error and it got an error. So we are going to open a context manager. So with pytest dot raises, so this is the context manager, and we check what is raised. For this case, it is a value, should be a value error, not values, a value error. And now we can create the employee object. So our employee, we could even call it just employee object anyway. So employee is going to be employee dot employee class. So we're creating this class, and we want to pass in values for first name John, then the other name is Jane, and then the other name is Do. So those are the first three names. The initial salary, we want to test it on a negative salary, so let's say negative 200. Then we pass in the date of birth, 1995. The month is September, and it is on September 17th. So this expects an error whenever this object is created, but are we sure that it's going to get an error? So let's get a terminal here. I'm going to check if this terminal is visible to you. I think it is. Great. So this is our working directory, and it contains the source, the tests, and the virtual environment. I think I should use this other terminal. I don't have another terminal open, so let's just work with this terminal. Terminal, new terminal. Okay. Clear that. Then just run pytest. So pytest is saying we have an error, and what's the error saying? An error uninterrupted. So no module named source. That means that it is taking another Python path. Remember, when we created this folder here, we put the Python version here, so I could just define the Python path from here. So we're going to export Python path, and this Python path is going to be here. So print working directory, and we export it as here. This is not going to alter any of my environment variables. Even if I had a Python path somewhere, it's just going to work with the session of this terminal. Whenever I close this terminal, the variable disappears. So I'm going to run pytest again. Pytest, and it's saying failed, did not raise. Yeah, so this test here that we have created, it failed, and the reason why it failed, it did not raise the value error, and we expected it to raise value error whenever this object is created with the negative value for salary. So now that the function is failing and the test is failing, and we have not yet written the class, we have not completed it, we expect this to be failing every time. So we are going to put a marker here to expect this class to fail, then we remove it whenever the class is fully written. So I'm going to put here a decorator at pytest dot mark dot xfail, and this decorator here tells pytest that this function here, this test here is expected to fail now because maybe something is to be done. So whenever I run pytest from here, we have only one x failed. So we shall have so many of them x failed until we complete writing our class. But for now, we are going to continue developing the pytest unit tests in different scenarios. So let me code the rest of the tests, and then get back to you for creation of this object, creation of the object. So all of them are going to be exfailed. Yep. So let me just get to coding. Right. So I have written some tests here, and mostly these tests are tests that expect the class to raise an error. So the next test that I'm going to write is going to be a test that is not expecting an error. So we're going to test employee object creation on proper arguments. So as you're writing unit tests, you need to be thinking in the direction of what are the scenarios where things are supposed to be failing, what are the special scenarios, for example, when working with the value of 0, or when salary is so huge. And then you need also to test for scenarios where things are supposed to be working. So this function that I'm going to write here is going to be a test for employee object creation on proper arguments. So let me write it. Yeah, so in this scenario we are testing the scenarios where an employee object is created with proper arguments. But after creating this employee object, we need to check that the variables that we have passed are the ones that we get for each. I mean, the arguments that we have passed are the values that we are getting for each variable. So this is why we have the assert statements, and these assert statements will fail if the value is not the same, and then that will fail. So we could try again, new terminal, and then I run pytest. Yeah, I don't know why I closed this. That export python path equals to pwd, then pytest. So we have 4 tests that are X failed. They have not started passing, but this is how we write the unit tests. There are other unit tests that you could write here. It's not complete. You would test on, for example, creation of an employee. The employee should be older than 18 years, so that whenever you're creating an employee who is less than 18 years, something should the test should fail if it successfully creates such kind of an employee. And then maybe checking also an employee whose age is greater than 78 years or some other age of retirement. Then we could also develop tests for the functions that we expect to write inside the employee class, which most of this I will leave it for you, but if I get time I will also write them and then link the code in the description, so you can find full test. But by this point I think you have a clear direction into how to write unit tests with on Python. So now what we are going to do next is to develop this class. I'm going to leave the manager.py for you and the tests for manager for you. If you write tests for manager and you develop the manager class that inherits from employee and you're excited about it, you can comment, put your comment and the link to your repo. I may give you a shout out in the next coming videos. So I will leave out the manager and the test manager.py for you, and I'm going to continue writing the employee class to be able to see how these tests will be passing. So let's develop the employee class. So each class that you always write, it's good to have a doc string, either in the, let's put it in the constructor. Command cut, remove pass, remove this, should be here. So the doc string should be here. Okay, hopefully that is the level. I think this is the level. Okay, so we say this class creates employee object. This class creates employee object. Then we start writing the class. So first name, we need self dot first name, and it should be this first name here. then self dot middle name, sorry, self dot middle name should be that middle name, then self dot surname should be the surname, and then the self dot salary underscore salary. So this underscore salary means that it's a variable that should be used within the employee. This is just more of a communication with the people who are developing with you, the people you're collaborating with. Then self dot underscore date. So this self dot salary is not supposed to be altered, and this is the communication to whoever is developing with you, that don't alter this date of birth. Should be this DOB. Then we are going to, let me close this. These ones are for you if you are well motivated. I'm going to remove these X fails for now for the objects that for the object that I'm creating, because I am working on it now and I want to make sure that they all pass the tests, or whatever I'm creating is passing a test, all the tests. So let's run pytest. Hopefully things work. We have one passed, but we have 3 failing, and one that is failing is on negative salary. That means that the object is created on negative salary, yet we are not supposed to be passing negative salary. So you're saying that unit test helps you to run several scenarios automatically. So imagine if you're to do this one by one, you'd run create an object, then pass that argument that you expect negative salary, see an error, go back there and do other stuff, then go and check. No, so here we have already written our tests, and now we are developing, and we make sure by the time all the tests pass, that means that we have exhausted all the scenarios and we have put them here. In our case, we have not exhausted everything, but in real life you need to exhaust every scenario and put here. But you don't need to do things incrementally. You can exhaust it by looking at the scenarios where you expect your unit, for example a class or a function, to fail, where you expect your unit to pass, and scenarios where you are special cases. So when you exhaust all of them here, then you can write your class or your functions and be testing them on the scenarios that you wrote. So here we are passing one, we have passed one scenario, but we have failed 3. And the first one is saying that we did not raise an error whenever we created a negative salary. So now we need to work with salary to make sure that a value error, because it expects a value error, is raised when a negative salary is passed. So we're going to do, first of all, there is a minimum salary that an employee is supposed to have, and there is a negative salary. And the minimum salary here, so we can use one bird to kill 2 stones. Minimum salary, for my case, I assumed it's 3,000. So this should be more than minimum salary, so that we're only testing one thing. I don't want it to control Z. Don't want it to fail and we start wondering what's happening. Yeah. So so for minimum salary is greater than 0, so we can just say anything below that is the value error. Hopefully also here we are expecting a value error. Nice. So we are going to define minimum, a global variable, min salary here, and the min salary is 3000. Then we're going to create a condition here. This is can put a comment and say test or not test, reject salary less than minimum salary. Then let's write that condition. So we say if the salary, that is self.salary, is less than the minimum salary, then we should throw an error. If self._salary is less than. So to access this variable here, we need to call the employee class, employee dot minimum salary. If it is less than minimum salary, then we should raise a value error. Raise value error, and see the salary cannot be less than this. So let's pass in just the same variable, and we put string concatenation here. So we are saying that else things are just fine, right? Yeah, if that, then else things are just okay. So when you run pytest again, so we have 3 passed. So remember the 2 tests, this one and this one, they are all capped by the minimum salary. Then I think this one is also passing, so the one that is failing is this, and it's saying that define test creation on wrong argument, did not raise value error. So it's expecting value error from this, but we didn't raise it here, so we need to write conditions to make sure that the value error is raised for the types. So here the type that we are looking at is the first name, the middle name, the salary. Yeah, and we could also add for date. We expect the date to be a string, so we could say and this. So again, I told you that this is not exhaustive, type not string, and this should be DOB. So let's put that condition in the constructor. So we're going to say that if the type of the first name, that is self.firstname, if the type of this, we could use its instance. Yeah, we should use its instance. If is instance first name, if first name is string, then we do nothing. It could work if we say it is not. So if it is not a string, if the first name is not a string, then we should raise value error What does it expect? We should raise a value error if the first name is not a string. So we're going to raise value error. Raise value error, and we say name not string. The same will work for let's just put them in a chain. If the middle name is also not a string, it should raise the same value error. Then if the surname is not a string, remember the syntax that I've used here is instance will return true if this variable is of this type, but now I'll put a tilde in front of it. Whenever it returns true, the truth will change state into false. So whenever this is false, then it will return that. So this is helping because it just catches here. If it reaches here, then if this is okay, then it will check this. If this is okay, then it will check, if this is okay, it will check this. If that is okay, it will check this. If that is okay, it will check what else are we checking? Salary. So salary should be an integer or a float. So if it is not an integer or it is not a float, I hope I'm writing something that is correct. So if it is not an integer, it will no, this is going to sorry about that. So here we're checking if the name is not a string, it will throw an error. If this name is also not a string, it will throw an error. If it's not a string, it will throw an error. But in this case, these are all surname. This should be salary. I think we should, since we're also expecting a date of birth, we should first work with the date of birth. If the date of birth is not a string, we should throw an error. But for salary, has two conditions. It could be either a string or an integer. So if salary is not an integer, it should check if the same salary is not a float. So within it, check this is not a float. So if it is not an integer and it is not a float, then it should raise an error. But if it is not an integer but it is a float, then it should not raise an error. So here I think we caught so many of them. Let's try pytest. 2 failed, and it's saying unsupported type error and not supported between. I can't tell. Oh, okay. Let's try this is less than. So let's try initial salary. Here. So here it is saying that wrong argument types, type error, less than is name is not string, in tests, sorry. So in test, we are supposed to expect, is it a type error or a value error? First name, what did we raise here? Value error everywhere. Oh, so we are expecting type error, not value error. I think. So it is giving us. Let me try changing this to the original. So first name, middle name, and surname, whatever was passed. Okay, here. Then this is DOB. Then initial salary. Then let me run pytest. Okay, so wrong argument types. Where are we seeing this from? So value error, name not a string. This is test employee creation on proper argument. Okay, so test employee object creation on proper argument, and it's saying that the value error, name not a string. I think I put like name not a string everywhere. I should say here, let me just name this salary not float or int. Then date of birth not string, DOB not string. Then here it should be surname not string, and then this should be middle name not string. Then this should be first name not string. When you run pytest, what happens? It's going to give us first name not string, and this error is failing because it's giving a value error. We are expecting a type error if it is not a string. I think it's failing on this. Not sure. Let me look at it. First, let me change this to type. We should be expecting type error on wrong argument types because it is types. I'm going to put this to type. Should be type. So this is going to throw type error, and the same for this. Checking, these are argument types, so raise a type error. Then pytest. Okay, so one failing, first name not a string, and the first name not a string is on proper creation. It is throwing a type error. And do we expect a type error anywhere here? No, we don't. So that means that we are creating somewhere something that is, this is the only place where we create something that is giving us first name that is not a string. So there is a glitch somewhere here. Let me look at how I set up this. I could decide to code it again. I want to see everything here. Let's do this again. We expect these errors here. Salary type error. Okay, so something is wrong with our function, and it is giving us first name not string. It is failing here, and I'm trying to figure out why it's failing. What if we used type? If type of this is not equal to string, remove this. Which error would it throw? Middle name not string. So there is a problem. There is a problem with this instance. So I'm going to use type not equal to that. And also this should be type not equal to that. And this date of birth should also be type not equal to integer. So date of birth is not integer, it should be string. So string, then this should be integer or float. Type of this should be integer, so not equal to integer, not equal to int. And if it is not equal to integer, we're going to check if it is not equal to float. Not equal to float. Okay, so let's do our pytest again. Yeah, voila, so everything is passing, our pytests are passing, and things are fine for the tests that we have written here. Again, I have to reiterate that not all the tests, we have not put all the tests. The tests here are not exhaustive, but the purpose of this is to show you how to write unit tests for the different classes. And I've left a challenge for you to create unit test for manager and complete the manager class. But if you can't, you can follow the link in the description and check how I complete the manager class and the test manager file. So now that we have this, and you remember at the beginning of this video, I showed you the way I integrated the repo with codecov and Travis CI. So we need to give instructions to codecov and Travis CI servers whenever we push our code to remotely. It should be able to automatically check if we are passing the tests. But before that happens, we need to have a file called .travis.yaml, a YAML file. So travis.yml, and this will contain settings that will happen within the Travis servers to help us to be testing our code base. So the language that we are working on here language is Python. Then the Python version. So Travis CI has several Python versions, so we could try to check the Python versions for Travis CI. Python versions for Travis CI. So it's not like Travis CI has all the Python versions, but we can check which one is the latest, and then that is the one that we could use on our project. Or remember, my project is based on Python 3.10.0, but the Python versions here we can see is going up to 3.9 dev and nightly. So we are going to use 3.9 for our case. So Python, and the version of Python is going to be 3.9. Then whenever that server is launched, what do we need? We need to install things. So the first stuff that we're going to install is pip install. We're going to put requirements .txt. So we're going to freeze here, pip freeze, and all those dependencies, we put them in requirements.txt. And these are the requirements that we need. There are several stuff, but there is plugin, there is pytest, there is Tomly, the dependencies for pytest majorly. Then after that, remember what we were doing. Export Python path should be equal to pwd, the normal stuff that I've been doing on my terminal. Then we need to also install codecov in Travis CI server, so that it will be whenever Travis CI completes the check, it sends the report to codecov. So pip install pytest coverage and codecov. So those are installation for code coverage. Then after that, we need to run a script. So script, and what we are going to be running here will be majorly the pytest that we were writing, but now we want to run pytest on only tests. But I want the coverage to be to look at the coverage of the source folder. So we want to see how much of the source folder is covered by code. That's why I've put the cov here. Just a minute. So so this is going to show us the coverage of the code, and then we are only doing tests by tests. It's like doing pytest here, pytest, then I say tests, so that it only focuses on the folder of the tests. Yep. Is there anything I'm trying to think? Yeah, so after this is successful, we need to send the report to codecov server. So after success, we're going to codecov, and this will just help send the report to the codecov. So now let's push this code to Git and see what will happen. So git add, git commit. I know there is a way to do commit here, but I just like typing it. Git commit initial push, git push. So we have pushed our code here, and we are going to refresh this and see. Now we have our code here. We have everything, but we can't tell. We can see that the tests are going on, but we can't tell how the tests are going on. So I'm going to click here, some checks. I'm going to go to details. Okay, so if you have integrated Travis CI with codecov, I mean with your repo, you can always go to Travis CI. So this is app.travisci.com. So travisci.com. I already created an account, so I can just sign in. Yeah, so we have this is what's going on. You see the tests that went through here, and we can check a source employee .py, and then it is telling us this is just the report that it sends to codecov, but this is Travis CI. What we want is to get this badge here. I want to, so when I click here and I change the format here to markdown, I want to get this and put it in the readme. So click here, markdown, get this. I don't get what's happening. Markdown. And copy. Then I go to my code, I come to the readme here, and I'm going to add that there. Then I'm going to git add this, git commit -m, add Travis CI badge, then git push. So when we look at here, we refresh, we can see this badge here, and it is showing us that the code is passing. But how much of this code is tested, we need to get that information from codecov. So when you go to codecov.io, so codecov helps us with checking how much of our code is covered. What's going on? Codecov.io. Okay, I'm going to log in. I already created an account. I'm very sorry, people are laughing on the background and I can't control it. Log in with GitHub. So there is this. And the coverage here, we can see that the source coverage is around 68%, but we need to add that report to our repo. What we are going to do is to try to get that. I can't remember where I got it from, so I think it is in settings. Yeah, it should be in settings. So settings, then badges here. So we want to add this to our readme. So I'm going to add it here. I want them to be side by side, so there will be no space here. So I'm going to git add this, git commit -m added code badge, then git push. So just to recap, Travis CI helps us to do automatic testings, that is continuous integration. Codecov tells us how much of your code is tested. So we can refresh here, and we can see codecov is saying 68% of our code is tested, and Travis CI is saying that our code is passing the tests. So you've seen this before in other repositories. This is how they integrated them. The Travis CI and codecov are free for open source projects, but they're not free for projects that are private. Yeah, so that is what I wanted to show you, how to do unit tests in Python. I have left a link on the description to the source code. It contains everything. Hopefully by the time the video goes out, I would have completed the tests for manager. But you can also write the manager tests and the manager class on your own, and maybe complete tests for employee, and try to integrate this with Travis CI and codecov, and see if you have these badges. If you have any other further questions, you can ask in the comment below. But until then, if you have learned something, please consider subscribing and giving us a like. Until the next video, be blessed.